Yo, 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 Mr. Elting here, teaching you how to factor trinomials with an a greater than 1. And before we start, a little trivia question. What do you think is this sound? Any guesses? I'll reveal that answer at the end of the video, if I remember. Now, the first thing you should keep in mind here is what the heck do I mean by factoring trinomials with a greater than 1? Can you give me an example of a trinomial with a greater than 1? Well, if you said something with three terms like x squared plus 6x plus 7, you're halfway there because that's a trinomial. However, with a greater than 1, a is actually talking about the first term because this is actually ax squared plus bx plus c in standard form. And so this a should be some number greater than 1. So in this case, it was 1. But now we're talking about, okay, what if it's a number higher than 1? So if you had something like this, where this number was bigger than 1, congratulations, you're right. And it really is no different than the problems we've been doing. It's just a little more tedious and painful. So let's just start on an example. We're going to start with, our last term here, factors of 20. And these factors of 20 should somehow add to give me 17. And because I have two positive signs, you should know I'll have x plus, and I've already made a mistake. And the mistake is, when you start this problem, we're used to doing x times x to get x squared, but now I have a 3x squared. So where the heck does the 3 come? And, well, we're multiplying, so what are factors of 3? The only answer is 1 and 3. So really, one of these should just be 1x, and the other is just going to be 3x. So it's actually not that much harder than what we've been doing. It's just sort of an extra dimension. And now we also have to consider that because of this 3x, it's not going to be factors of 20 that immediately add to 17x. It's factors of 20 times something else that then adds to 17. So let me give you an example. Let's list some factors of 20. And this is actually the way we'll do this every time. It's sort of like guessing and checking. And by sort of like, I mean it is entirely like. So here's 1 and 20. What are the other two factor pairs that give us 20? You should get 2 and 10, and also 4 and 5. And notice how I write the leading one in order. And when I look at these, let's just pick 1 and 20, for example. I'm going to write it above 1 and 20. And let's see here. What is 3 times 1? It's 3x. And 20 times x is 20x. And it might help to write this in the box method if you like, because some people get really confused just looking at the parentheses. So essentially now I'm saying that this is 1 and this is 20 when I have 3x and x. And we're trying to get these two right here. Basically, you already know that's 3x squared. You already know that this is 20. We're trying to get these two boxes right here to somehow add and to give us 17. And this is clearly not going to work. This is going to be 60 plus 1. No bueno. And the other way around isn't going to work either. You're going to get 20 plus 3. And one of those can't be negative. So this one is just off our list. And, from the get-go, 20 was probably a little too high, honestly. Because that that's already bigger than 17. So how could you go backwards if you were adding? So really that leaves you with just these two options. So pick your favorite and just roll with it. I mean, I'll just sort of continue this. Let's just assume you're going down the list. 2 and 10. If I do 2 and 10 this way, you'll get 13x plus 2x. That's close, but not quite. If you do it the other way around, and you get 10x plus 6x. That's really close, but not quite. And so now we move on to 4 and 5. And this, as you can see, takes a little while, but persistence pays off eventually. Which do you think is right? X plus 4 times x plus 5? Or do you think the other way around is right? X plus 5 times x plus 4. If you do it correctly, you should actually get x plus 4 times x plus 5. And the reason I know that is 4 times 3x is 12x. And then the 5 times x is just 5x, so 12x plus 5x gives us the 17. And I know that took a long time, but it was not impossible. The next one, even harder, because now let's break this into its factors. You get 1 and 4, but also 2 and 2. Go ahead and factor 18 and list all the factors for me. You should get 1 and 18, 2 and 9, and 3 and 6. And if you get those correctly, we're just going to do our old guess and check. So if you have a sheet of paper handy, this would be a good time to get it out. We're going to do a lot of guessing and checking. You know you need 18 here. You know you need 4x squared here. And the question is, what is the combination that's somehow going to add up to 18x? I'll let you work it out. Just work through, see if you can't guess and check and see what you come up with. If you guessed and checked correctly, you should have found that it has to be 2x and 2x. And from there, we're just, again, guessing and checking. You actually should have found that it was 3 and 6, because if I do it this way, you know that 2x times 6 is 12x, and that 2x times 3 is 6x, and that the sum of 6x and 12x happens to be 18x, which is our answer. So we finally got it. Whew. It did take a lot of work, though. Now, I want to give you a bonus one, because this one we have a negative sign. And I do want to keep in mind that because of this negative sign, remember the rule? Factors of 30 that subtract to give us 57. Oh my gosh. So this time, basically, you're going to have, here's your square. You're going to multiply two factors of 6 to give us 6x squared. So you have a choice there. One has to be 1 and 6, or the other has to be 2 and 3. That's your choice. And we also have factors of 30, but one of those factors has to be negative to give us the negative 30. And that means that you can't just sort of go blindly and carelessly. You actually have to pick which one goes where based on your original 2, and that can be really painful. So I'll let you try to work this out. It takes a lot of guessing and checking. But start by listing the factors of each, and then just sort of plugging things in and seeing what you get. If you did this correctly, you should find that this is actually going to be 3x times 3x. And then the factors that actually work, 10 and you should, oops, I did that wrong. It's not 3x and 3x at all. It should actually be 6x and 1x. Changed my mind. 6x and x. And you can see how hard it is. I can't even do it in my head. I really have to think about this, even though I wrote the problem down just a couple minutes ago. And so if I'm now thinking a little more deeply about it, I know that this actually should be 10, and this should be 3, 60x minus 3x gives me 57x, and that's painful, but I got it. Congratulations if you got that correct. This just takes a lot of practice and a lot of patience, a lot of patience. If you like this sort of work, maybe you'll be good at combinatorics. That's the science of code breaking, which involves a lot of this kind of stuff. Pretty neat. Hopefully you're starting to get it.